broadcasting from Studio 202 at the Springett Technology Center in Navasota, Texas. It's NOV Live. Now, let's start the show.
Hello, good morning, good afternoon, good evening. Welcome to NOV Live. My name is Shelby Dumaine. I'm so excited to have you joining us here on NOV Live. Every week we talk to experts here at NOV about the technology that they love and that they're passionate about, and we bring that to you so that you can learn a little bit about it yourself. And we have a really great show today. We're talking about how NOV is pushing to be the leader in MPD, or managed pressure drilling. And before we get into that, we have a little bit of a Rig Geek trivia question that we're going to ask here. If you're familiar, we're going to ask you a trivia question, and you are going to guess the answer. So we'll get right into that with the Rig Geek Post of the Week.
Rig Geek's Post of the Week.
All right, so here we go. This week's Rig Geek question, and we'll have it on the screen as well. We have, on a land rig, what sits on top of the BOP to create a closed loop system? So if you think you know it, go ahead and put it in the comments. Again, what sits on top of a BOP to create a closed loop system? All right, if you put your answers in there, if you put your best guesses maybe, wait till the end of the show where we will reveal that answer. So stick around. And speaking of the comment section, if you have any questions for our expert today during the show at any point, go ahead and put your questions in the comments. We're actually going to do a live Q&A at the end of the episode. So if you stick around to hear your Rig Geek question, you can also stay for that live Q&A and have a chance to have your question featured live on the show. All right, and with that, we are going to get right in. I don't want to delay you meeting our expert any longer. So here on the show from our MPD group, we have Austin Johnson. He is the Technology Development Manager. Good morning, Austin.
Good morning. Thank you for having me.
Absolutely. I'm really excited. And so if we can just start off with kind of the basic question, what is MPD? What does that mean? Can you explain it for our audience a little bit, just at the base level, what managed pressure drilling is?
Yeah, sure. So MPD is an adaptive process where the rig actively controls the annular pressure profile in the well. There are several types of MPD, but the most common is the applied surface back pressure method. In a conventional drilling application, the wellbore is open to the atmosphere at the surface, and so any friction pressures which act on the well take effect downhole in the open hole formation, and this is usually the most sensitive part of the well. In an MPD application, we enclose the well at the surface using an ACD or an RCD, and this allows us to attach an MPD choke to the well and variably adjust the surface pressure. And so what we do with that is we basically adjust the surface pressure to compensate for the loss of friction pressure as we go into connection. And so this allows us to maintain a constant bottom hole pressure in the open hole by varying the pressure at the surface. This is a much better way to do it because the most sensitive part of the well is protected, while the surface can be engineered, and we can engineer the safety into it. So this is a better way of drilling, which allows us to prevent drilling issues from occurring or substantially reduce their impact on the well.
Right, so it's giving more control to the drilling process. Is
that's right? Yeah.
Excellent. So I know from if some longtime viewers, they know that I'm helping with the posting on our LinkedIn, and I saw recently come across our recent acquisition with AF Global. So can you tell us a little bit, how does that position our MPD group to better serve the industry and really better serve our customers?
Yeah, absolutely. The NOV edition of AF Global is really further strengthening our core business and allowing us to provide a complete array of MPD products and offerings for all MPD applications. In deep water, our active control device allows the rig unprecedented control over the wellbore seal and visibility into how that seal's performing in real time. So whenever the seal reaches the end of its life, we can trip it out before a failure occurs. In surface BOP applications, our RCD systems basically give the ability for the rig crew to perform all bearing maintenance on location using simple hand tools and procedures. And this allows us to reduce the cost of performing a hard and soft redress of the bearing assembly. Our MPD manifolds are tailored to the specific needs of the drilling operation, so the operational needs and the footprint requirements of that rig. And then our integrated systems allow us to bring all these different digital feeds in together and really provide additional value to the rig by optimizing how we feed data across the rig. So altogether, NOV is positioned to provide a comprehensive offering of MPD equipment, aftermarket service, and data management to fit every need in the MPD business.
Wow, that's pretty big. That's
Yeah.
huge.
Yeah.
That's awesome. And I know, so we had talked about this a little bit. This is going a little off course, but I know we'd mentioned it, and you talked about hard redress and soft redress. Can you just, I'm not familiar with it. Can you explain to me what that is?
Yeah, so hard redress and soft redress are the terms we use to describe overhauling a bearing. Typically, when an RCD bearing comes out of the well, the rotary seals have been used, and so we don't want to put that right back in the well without checking their condition and replacing them. So when we pull the bearing apart and just replace seals, that's a soft redress. When we pull the bearing apart, take all the seals out, and take the bearing out of the assembly, that's a hard redress.
Okay.
So it's the soft pieces versus the metal bearing pieces.
Gotcha. I want to make sure, because
yeah.
I heard you mention that, and I know we had talked about it, so I was like, wait, I want to kind of connect those dots, so thank you.
Yeah.
And can you talk a little bit, what are some of the ways that we are differentiated from other MPD providers in this space?
Yeah, sure. One way that we're differentiated is how we go about innovating. NOV is one of the only MPD service providers who designs, engineers, and manufactures our equipment in-house. And this provides us an advantage in the manufacturing, troubleshooting, and repair of equipment. But this drive toward innovation really goes back several years. When we entered the MPD space, we were basically a manufacturer for other service providers' MPD joints in deep water. We basically built the systems and delivered them. And after building a few dozen of these gas handling systems and MPD joints, we started to see some of the issues that the operators of that equipment were having in deep water. And it was all related to the use of passive RCD technology, which was adapted from land. So as this technology was brought to deep water, it had to be scaled up, and then there had to be additional preparations and operations to protect the sealing surfaces and prevent damage to the bearing assembly during run and retrieval. So this basically spurred us to take a clean sheet approach and completely rethink how we seal the wellbore in deep water. And this led to the development of the active control device. Now, the active control device takes a completely different approach to sealing the well, and it eliminates the most common failure modes of a passive RCD system. And it's all based on equipment that drillers sort of intuitively get, and it provides a very robust sealing solution for deep water.
Awesome. Yeah, that's something I've seen with a lot of, I think, technologies, but MPD in particular, NOV, is the ability to kind of spot a place where we could improve on for our customers and do something and actually change it, because we are, like you said, kind of involved from the creation to the beginning to end of our products and MPD.
Yeah, and there's more to that too. Another one of our differentiators is how flexible we are. When it comes to drilling, there's really rarely a case where one size fits all. And designing drilling equipment is definitely a case where one size does not fit all.
Right.
So when it comes to delivering an MPD specialty joint for deep water, rather than building one part number and carbon copies of it, We basically take the approach to adapt the MPD equipment for the specific needs of the customer. So whenever we set out to build a specialty joint for a client, we start by sitting down with them and looking not only at the one target rig where MPD is scheduled to go, but we look at their entire fleet. And the things that we look at include the different riser systems that they have from one rig to the next, and any existing legacy MPD equipment that they may have, like riser interface joints or riser gas handlers. And so this allows us to basically put together a strategy for equipment management for that contractor. And so some cases, it looks like us providing a unitized joint where you have all the subsea functions on one single riser joint, and where the flanges mate directly to the OEM riser on that rig. And in other cases, it makes a lot of sense for us just to provide a carbon copy of equipment they've had in the past, and use riser interface joints to cross over between different rigs in the fleet. So we take a very flexible approach on that.
Yeah, that's excellent. Yeah, that's what I've noticed doing this show and seeing the comments out there. Sometimes when we get questions, it's almost can be hard to answer because it's like, oh, it's so different from customer to customer. But I think that's really something that's key, is hearing that it's okay if it's different from customer to customer. We kind of thrive on that system.
Yeah. And there's another way this flexible approach shows up, and it's how we integrate systems on board the rig for MPD operations. In some cases, we'll see an operator has already agreed to use another service provider's manifold or hydraulic model. And so rather than letting that be a roadblock to serving that customer, serving that operation, we take an open architecture approach with our control systems. And so this allows us to basically feed information back and forth from our system to a third-party system. And this allows them to control our equipment as needed. It allows them to visualize what's happening with our equipment in their HMIs. That basically allows us to reduce the amount of standalone equipment and the standalone feel of the system. And it's all driven by how the end client prefers to see it laid out.
Yeah. Wow, very cool. Really I never realized how customizable it can be. So that's really fascinating. And I know you mentioned, years ago when we kind of got into the MPD space, and we've been around in that space for a little bit. Can you talk about what's new to MPD?
Yeah, sure. So MPD has changed quite a bit, and there's some very interesting things happening, especially in deep water. 10 years ago, it used to be very common to see MPD run as a third-party service, where all the equipment was owned by the service company, and they would send a crew of their own engineers, supervisors, technicians to the rig to then run that equipment. This approach basically led to increased cost of the service, as well as duplication of roles on board the rig. And so what we've been seeing recently is an uptick in the number of drilling contractors who are taking complete ownership of the MPD process from end to end. So basically what this looks like is us as an OEM providing equipment to the rig, then training them on how to use it, and supporting them with aftermarket support and software to help them continually optimize the system. This approach has been used now in several implementations around the world. Currently in the Gulf of Mexico, we have 3 rigs running that are all supported by a single technician.
Wow.
Yeah.
That alone is, I feel like, a big statement. That blows my mind to hear one person can be operating multiple.
Yeah.
That's really awesome.
Yeah. And so that's in the deep water space. In the onshore space, what we're seeing is really a drive to drive the cost out of MPD. 10 years ago, it was very common to see an RCD bearing owned by a service provider. When it would come out of the well If it was timed out or near being timed out, it would get put on a truck and sent back to the shop. And then that bearing would be disassembled, inspected, cleaned, all that by a highly skilled technician who only worked on bearings. It would be rebuilt and sent back to the next operation. And this was just a way of doing business that increased the cost of using an RCD. The way we're doing things now is basically designing all the complexity out of the assembly and disassembly process. So this is allowing a mechanic or one of the people on the rig to take the bearing apart after it's timed out and perform all of the inspection and redressing of the bearing on location without compromising the performance of that bearing.
Wow. I've heard with a couple of our products here and there of being able to do stuff on location, and still every time I can sense how big of a deal that is, and to be able to have that flexibility and kind of, like you said, get it done there.
Yeah,
I feel like
it's really a big deal when, instead of calling out a truck to take the bearing to the shop, being able to take the spare parts to the rig in a box or in a backpack. It really changes the cost structure of operating that equipment.
Absolutely. On the most smallest of scale for me, I know I'm always worried, what if my car breaks down like at my apartment, and I don't have to pay for a tow truck. So the thought of when I heard that sometimes mechanics can come to you, that, I don't know, put me at ease. Might be a silly thing, but that's how I relate to that, and how big of, how important that is to be able to have that come to you and be able to fix it there. I think is really excellent.
Yeah. The only thing we really need to provide outside of the spare parts is the know-how, but the capability, it all exists on the rig. One other area where MPD has really changed a lot is in how systems are integrated on the rig as well. 10 years ago, it was very common to see MPD run as a third-party service. And so you'd have everything that implies, where you have equipment that's brought to the rig on a temporary basis. You have a crew that's communicating with the rig crew with walkie-talkies, and you have standalone HMIs cluttering the driller's cabin. So we've recently been seeing as well a big push toward integrating all of these different systems, and this helps tremendously with data management and troubleshooting and security and safety of the MPD system. And all this is a place where NOV is particularly well suited to help.
Yeah, that's excellent. And I also wanted to ask, normally I try not to ask too often for our guests to look into the crystal ball and tell the future, but I got permission from you. So can you tell us what the future in MPD looks like, especially for NOV?
Yeah. I'll definitely tell you some of the things we're working on. In deep water, we continue to develop the active control device technology. One way that we are continuing our development is looking at the seal sleeve element design and reevaluating it so that we can get more life out of the seal elements. Currently, they typically will be replaced each time the BHA comes out of the well, but we have the goal in mind to run these things for multiple sections, weeks worth of drilling. And so that's where we're working on seal sleeve elements. But the ACD technology particularly has applications in other types of MPD as well. So we're looking at using the ACD system in a controlled mud level dual gradient drilling process, as well as a post-BOP riserless drilling system. So that's where we're going in offshore. Onshore, we continue to see this push toward bringing the cost out of the MPD equipment and making the system easy enough so that it can be run really by any rig crew anywhere. We've seen this before with the top drive, for example. It used to be a sort of special service that was brought to the rig, but now it's on every single rig.
Yeah.
And for MPD to get to that point, basically we have to focus on reducing the complexity of the equipment for maintenance, reducing the complexity of the control system for operation. And we have to really tailor the system so that the rig crew can pick it up, turn it on, and start to get value out of it from day one.
Yeah, absolutely. And it sounds like our acquisition with AF Global is kind of is part of what's helping that, along with our technology. I feel like to get to that point. Is that would that be fair?
Oh yeah, absolutely, absolutely. The bearing technology, being able to service equipment on location, that's part of this overall drive toward moving the ownership of MPD from third-party services into the drilling contractors realm.
Absolutely. And before we go to any audience questions, I wanted to ask you really quick. I know I saw one asking if there were videos kind of showing some of this or any further information. So where might folks go to learn a little bit more about MPD?
Yeah, they can come to our website, the MPD page on NOV's website.
Right, and I think we have that, so we can show it on screen. Coincidentally, we normally would show it, but then I actually saw a question. I was like, oh, actually, I can help that person out. But we'll show that on there. That's nov.com/MPD. I believe you can check it out. We made it simple. You can go there. But I also wanted to give our audience a quick chance to ask their questions. So if you still have questions, go ahead and get those in. But to start off, I wanted to ask a question from Ahmed on LinkedIn. And I'm going to add to his question a little bit because I think it was a great one, and I want to push a little bit further, poke a little more. So he asked, are there any 3D simulations or any other ways to test our technologies?
Yeah, so we actually have quite an array of ways to test technologies. With MPD, quite a bit of our focus is on surface equipment, but there's also quite a downhole component to it as well. NOV specifically has world-class testing facilities here at the Spring-It Technology Center, the drilling rig that's sitting outside. But then when it comes to testing riser equipment, we also have at another facility a full-scale testing system to basically take the riser joint and run drill pipe through it with the same conditions it would see in the field. So live drill pipe with hard banding, rotation and reciprocation simultaneously. This allows us to do drill mode testing and really vet systems before they go into the field.
Oh, that's awesome. And this next one comes from Lauren. What's the difference between closed loop drilling and MPD?
Well, MPD, as we described, the applied back pressure form, is a form of closed loop drilling. A closed loop drilling system is basically formed when you stop venting the pressure to the atmosphere at the surface. So you have an RCD at the surface, and all the returns are then forced out of the well into some mechanism for measuring and controlling it. So really the main difference is, do you actively control the choke pressure, or do you just monitor the flow out of the system enclosed with an RCD?
Okay, yeah, and I'm always still trying to get the acronym straight. I do know MPD, which is managed pressure drilling. But can you really quickly remind me again what RCD and ACD is? I think you said it earlier, but I want to get it down.
Yeah. So an RCD is the acronym for the rotating control device.
Gotcha.
And that's a form of a passive wellbore sealing system, where the elements are basically a giant rubber band, if you will. And in order to reduce the wear that's caused by pipe moving through it and rotating, the inner portion of an RCD assembly rotates with the pipe. So effectively, the seal elements only see the sort of translational motion of stripping pipe through, and then the bearing portion of it sees the rotating portion of turning the rotary on. So there's a lot of different parts in an RCD. You have static OD seals between the bearing assembly and the housing. You have the rotary seals between the rotating portion and the non-rotating portion of the bearing, and then you have the sealing elements, which are or one or two above and below the sealing or the bearing assembly.
Okay. Okay.
So they're really effective onshore and in jackups because they have a short stack height. One will be about the size of about the height of a table, and so it's just a very short height that can be easily put under a rig floor. But where you get into deep water, taking that technology for larger riser systems and deploying it subsea 100, 200 feet, it's not really optimal because you have to protect the OD seals on the bearing, and there's just larger diameters you have to work with, so it increases the rotary velocity. It wears the rotary seals faster. So this is why we offer the ACD for deep water. The ACD eliminates all the rotating parts from the seal assembly. And so the way the ACD works is we have a retrievable assembly, which is run into a housing. On that housing, we have two annular packer systems, which correspond to an upper and lower sealing element in the seal assembly. And when we close the ACD, we basically close the packer on this retrievable element, and that makes it deflect inward and contact the pipe. So this system works really well for deep water because if we wear the element, we just close the packer a little more, and then once the durable piece is worn away, we can still function it. So it's a really robust solution for deep water sealing.
Okay, yeah, I've been making it a goal of mine. If I hear an acronym that I don't know right away, I try to ask it, especially if I have an expert here. I mean, how could I not? But before I get to, we actually do have another one from Brian. But before I get to his question, what is I'm always curious with stuff with deep water. What's the maintenance look like on something like ACD?
Yeah, so the maintenance on the ACD is fairly straightforward. Fundamentally, it uses spherical annular packers, and this is equipment that rig crews are very familiar with. They already exist in the LMRP, so they understand spherical packers. Whenever we deploy the ACD, basically we're just doing a checklist. Let's make sure that all of our sensors are working. Let's make sure that all these rotating pieces, the ball valves on the assembly are greased and ready to go, and that there's nothing obstructing the inside. And when it comes out of the well, we do a very similar process. And then every couple of years, we replace the packers and the elastomers inside the ACD. So it's a very straightforward maintenance program, and it's a very robust piece of equipment to begin with.
Yeah. Okay. Interesting. Thank you.
Yeah.
And I like I said, I promised Brian we'd get to his question. And on LinkedIn, he asked, do you use downhole pressure from LWD or acoustic tools to calibrate/validate the MPD back pressure?
Yeah, that's actually a very common practice. Basically, the process before we go to drilling an MPD section is to run in the hole with the BHA, and before we drill out cement, basically we'll set up our hydraulics model in the control system, and that typically will get us about 98-99% accurate, maybe a little more, and then the standard practice is basically use the PWD, the measured value, to calibrate the hydraulics model. So this basically gives the choke controller the instructions whenever we ramp down the pump and that downhole tool goes away, or the mud pulse telemetry goes away. We give the choke controller visibility. We tell it, hey, do this according to the model, rather than relying on a PWD tool.
Okay. And another silly acronym one. So I know MWD is measurement while drilling. Can you remind me what LWD is?
Yeah, LWD is logging while drilling.
Logging while drilling.
So,
I was on the tip of my tongue. I was like,
Yeah.
I know this one. Well, thank you so much for answering our audience questions. And I wanted to mention, if you are watching and you have another question or you think of one later, you can still get that to us. You can email us at socialmedia@nov.com. Or like I said, you can even go to nov.com/MPD, and there's a contact the team feature there. So you can, either way, you can get to us. We want to make sure we get all of your questions answered. And speaking of answering questions, I want to answer that Rig Geek question from the beginning of the episode. So we're going to get it one more time on the screen here. You still have a few moments if you think you know it. I always, I'm sure to the annoyance of some people, I always try to stretch this out, give you a little bit more time. But we asked you, on a land rig, what sits on top of the BOP to create a closed loop system? And to answer that, could you answer that for us? I think you might have mentioned it if someone was really listening close, but what is our Rig Geek answer?
Yeah, the Rig Geek answer is an RCD, or rotating head.
Excellent. Thank you very much. There you go, folks. If you got it, congratulations. You are absolutely a Rig Geek, and we love that. If not, keep guessing. Every week we do these questions, and so we love to see everyone in the comments trying at that. And with that, that is our show. Thank you so much, Austin, for coming on and lending us the expertise. I've certainly learned a lot, and I'm sure our audience has as well.
Yeah, thank you for having me.
Absolutely. And if you're watching this and want to watch any past episodes, you can find all of those at nov.com/live. You can join us every week here on Wednesday. We go live talking to external industry experts, talking to our internal experts, and we look forward to seeing you next week. Have a good day.